Hi friends, so this video is going to talk a little bit about logarithms, and I'm going to show you just a couple of examples of logarithms, and we'll see some definitions in just a minute. So the first thing that I want to make sure that you understand about logarithms is that a log is the inverse of an exponential function, which means that we can evaluate any logarithm by simply thinking about what it means in terms of an exponent. So just like an exponent, a log has a base, which is conveniently written a little bit lower down so that it's a base of a number. And the base, the log sort of undoes the exponent. So basically this is saying 3 to the what power, we don't know the exponent here, gives me 81. Okay, so 81 is the log base 3 of 81 is the exponent that 3 is raised to give you 81. Okay, so this part is called the base, the 3 is called the base, the 81 is called the argument. Okay. And the log base 3 of 81, or the power that 3 would be raised to give you 81, is 4, because 3 to the 4th power is 81. Log base 2 of 64 says 2 is raised to what power to give us 64? So the answer is 6. See if you can do this one before I write it down. So log base 5 of 125 means 5 is raised to what power to give us 125? And the answer is 3. Now we have to be careful with logs because we can get into cases like this. So this log base 2 of 0 means 2 is raised to what power to make an argument of 0 or make an answer of 0. And I could put in a negative. If I put in like -1, it would be a half. If I put in like -100, it would be 1 over 2 to the 100. But there's no number that I can put in here that would make the argument equal 0. So this has no answer, no solution. Okay, so there are some restrictions right here that we're identifying. The argument, it looks like, can't be 0. Same thing goes for a negative. 3 to what power gives me -27? There's nothing. There's nothing I can put in here. So as my math teacher used to put, DNE does not exist. There's no answer for that. And then sometimes we have to be careful about the base here, because if I try to raise 1 to some power to get me 5, well, there's no number of times that I can multiply 1 by itself and get an answer of 5. Okay, so that's not going to be a solution. In other words, this is just a summary of what we had on the page before. You can pause this and take some notes here if you want to. But just to make sure that we're thinking about this right, the base is restricted. The base itself is, and so the base here, right, is a number that's greater than 0 but not equal to 1, because if it is 1, it can only, the argument can only be equal to 1, right? It can only be 1 to any power, still gives you 1. And the argument has to be greater than 0. So what's basically in the logarithm, right, has to be a number that's greater than 0. Okay. Some quick tricks or some quick things to know when you're dealing with logs is that 20 to what power will give you 20, right? So if the base is the same as the argument, then the answer is just 1, right? And anything that has an argument of 1, right, the log of any number that gives you 1 is always 0, because anything to the 0th power, any base to the 0th power is going to give you 1. And then similarly to the first one here, if I want to know what power I raised the base of 3 to get 3 squared, you're going to notice that the log of this, the log base 3 of 3 squared, is just going to equal whatever that exponent is. Okay? So just some quick things to recognize and notice when you're dealing with logarithms. Okay. One of the easiest ways to solve a basic logarithm function is to just rewrite it as an exponential function. So these are actually already answered, but just to remind us how we would rewrite this, we just take the base, right, and 8 to the second power is equal to 64. So this 2 here becomes the power, right, and the 64 becomes the answer. So you have to be a little careful because they sort of switch places when you're dealing with it. And it makes sense that they switch places because you're taking because they're the inverse of each other. So we're sort of switching the input and output. Okay. Same here. Here I'm saying the base of 2 to the negative 6 power is equal to 1/64. Okay. So we can use that trick of rearranging a log as an exponential equation in order to solve it. So I could rewrite this log equation as an exponential equation, so write its inverse, and then use that to solve it. So here, for example, I would rewrite it as 3 to the 4th is equal to x, and so I would quickly see that that's 81 is equal to x. Here, I would rewrite 4 to the 1st is equal to x minus 2. And then I could just solve for x is equal to 6. I have to be a little bit careful when I'm solving log equations because I have to make sure that the argument is still valid, right? Remember that the argument has to be greater than 0. And remember that your base can't be 1, right? It has to be larger than 0 and not equal to 1. So as long as that's true, then I'm okay. So log base 3 of 81, that's fine. I can do that. And here I've got the log base 4 of 4, because 6 minus 2 is 4. And so that's fine. I can do that, and that is 1. And notice this is our rule from before, right? The base and the argument were the same, so the log is 1. Much like exponents, when you're solving log equations that have logarithms on both sides, it all comes down to the base. So if the bases are the same, we're really just saying that the arguments also have to be the same. Okay, so if you're taking the log of base 4 and the log of base 4, then the arguments must also be equivalent. So I can just go ahead and solve this like I would solve a linear equation. So 6 is equal to p plus 10, so subtracting 10 from both sides. Negative 4 is equal to p. Now I have to be careful. I've got to plug that back in, right? Because remember, my argument has to be larger than 0. So fortunately here, when I plug this back in, I end up taking log base 4 of negative 4 plus 6, so that's 2. So 2 is okay. And here I'm taking the log base 4 of negative 8 plus 10, which is also 2, and that's okay. That's a legal operation. Over here, let's do the same thing. So notice the bases are the same, log of 19 and the log of 19. So I can just set the arguments equal to each other. So let's add x on both sides. And that gives me 6x is equal to 0. And dividing both sides by 6x is equal to 0. But here, notice if I plug this back in, 5 times 0, that's 0. And I can't have an argument of 0. So that's not a valid logarithm. And over here, if I were to plug this in here, I'd end up with -0, which is also 0, which I also can't have. So this actually has no solution because this solution creates a situation in which I have a log that I cannot take. Okay, so you need to be a little careful with your arguments when you're solving log equations. Okay, and that's actually all I have for basic questions on logarithms. So there's some practice work to see if you can work through all of these, and I hope that you will come to class with any questions. Thanks.